Okay, ladies and gentlemen, what we're doing today is starting our unit on quadratics. This is a picture of the parent quadratic function. Notice the equation is y equals x squared, or f of x equals x squared. It is of a U shape. It's technically not a U because at the very top the arrows are indicating that it is widening for infinity. But it does have a general U or smiley face shape. Now this quadratic has several characteristics, and I'm going to come over here. We'll talk about some of the vocabulary. You need to know and be able to apply these vocabulary terms. First of all, every point on a parabola has a vertex. We're going to call this H comma K. It's still an XY ordered pair, but we're going to give it a nickname, H and K, because when we go to the vertex formula of a quadratic in a later lesson, you will see H and K, and you'll just know, hey, that's the vertex. This is the point where the parabola changes direction. So over here, so we take a look right here in quadrant 2. On the left-hand side, if we were on the top, we were on a roller coaster car, we were coming down, screaming is the fun part, and down at the very bottom, this would be the vertex, because this is where it changes direction. In quadrant 2, it's going down and moving from left to right, and once you get into quadrant 1, it starts going back up. So this would be the vertex. Now the vertex is either at the bottom or top of the parabola. In this particular case, it is at the bottom. It's kind of like a valley. So as we take a look at this, the vertex is the lowest or the minimum point. If it's turned the other way, it would be called a maximum point. We'll deal with those in a couple of lessons. We still have a y-intercept. It's the point 0 comma something, where it crosses the y-axis. But we also have some new things. Most importantly is the 0. 0 is a nickname or another way of identifying the x-intercept. It's also called a root, or it's called a solution. And it's the point something comma 0. So in this particular case, we do have one point that touches the x-axis, and that would be the origin again. So in the parent, the vertex is also the y-intercept and the x-intercept, as well as the minimum point. It's the most basic. Now, one of the things that really helps out is noticing that parabolas have symmetry. So if you take a vertical line, you'll be able to cut every parabola in half, and they will be identical. So it will always go through the vertex. The vertex and the axis of symmetry are connected to each other. So that's the vocabulary that I'm going to be referring to as I go through some of these problems. So this was from the first day back, part 1. Today we're going to be looking at the parent and what happens whenever we add something to the parent. So in each one of these, we're going to want to put the parent on the grid. So this is f of x equals x squared. So we're going to be multiplying a number by itself. So the quickest and easiest way to do that is to go to your calculator, type in x squared, and then go to your table. These are the ordered pairs that you need to put on your grid, and we're going to go with a domain from -3 to +3. So we're going to come over here and we're going to graph these ordered pairs. So -3 times itself is a +9. -2 times itself is a +4. So -2, 4. -1 times itself, a negative times a negative is a positive. We have 0 times itself is 0. 1 times 1 is 1. 2 times 2 is 4, so 2 comma 4. And finally, 3 times itself is 9. Now if we connect this, we have our parabola, our parent parabola. Okay, so this goes through the origin. Its vertex is 0, 0, and it has a x-intercept of 0. So now we're going to ask ourselves, how does this function compare to the parent? It has the x squared component, but we have something tacked onto it. So what we want to do is we want to go back to our calculator and utilize that as much as we can. We're going to just go over here and put a plus 3. And as we go to the table and we fill it out, we'll notice that it's not just negative 3 times itself, which was 9. Then we got to add 3. Well, 9 plus 3 is 12. 2 squared is 4, but if we add 3, we get 7. Negative 1 squared is 1, but if I add 3, I get 4, and so on. 0 squared is 0. So it's just easier to come over here and copy down the output values from your calculator, because we want to make it easy, right? So now we can come over here and graph these points, and we're going to compare it to the parent. Okay? So we have negative 3, 12, which is off the grid. We'll now do a negative 2, 7. 1, 2, 3, 4, 5, 6, 7. Okay? So you see that this input of negative 2 has changed it. It's translated it up, and that's going to be important when we answer some questions later on. So negative 1 now has an output of 4. So negative 1, 1, 2, 3, 4. I've got 0, 3. 0, don't move any right or left, but go up 3. I've got a 1, 4, and I've got a 2, 7. Okay, so if we connect this one right here, that is our new graph. Now, back on the vocabulary that I showed you, a 0 is an x-intercept. You're not guaranteed to have an x-intercept. If you look at this blue graph right here, it does not cross the x-axis. So there is no zeros in this problem. So we can say none, or we could say not applicable. And sometimes you'll have 2, but in this case we have no x-intercepts. Not applicable. Just don't worry about it. They're not there. Look at the picture. It doesn't cross the x-axis, so don't go trying to find it. All right, but we do have the vertex. The vertex is where it changes direction. So if I'm on a roller coaster, I'm coming down, 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 down. I hit the bottom, and then I change direction. I start going up, 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 up. So this is the point where it changes direction. So this is the vertex. The vertex is 0, 3. So whenever x is 0, in this particular case, we're going to have that. So we have 0, 3. Now remember, it is the lowest point, so it is a minimum or maximum. It's the lowest point. It's a minimum. It's a valley. Okay? Now, when we first started out, we said that we were going to give new letters to the vertex. Instead, we know this is an x and a y, an input and output, but we're going to give it a nickname. You remember? This one is going to be h, and this one is going to be k. So if we look at the y-intercept is also the same point as the vertex. It won't always be, but in this case it is. Okay? And remember, we now have symmetry. We can come over here and we can slice this thing in half along this vertical line. If you remember your Hoivux, a vertical line is x equals. So if you look at your vertex, your x-coordinate is 0. So when you come down here, remember these are tied together. Your vertex and your axis of symmetry are tied together. X equals what? X equals 0 is going to be your line of symmetry. Now, what's your value of k? Your k is 3. And I need for y'all to notice that that 3 is the difference between the parent function, y equals x squared, and the one we're dealing with right here. Okay, so this is in the form of x squared plus k, and k winds up being 3. Notice it appears in the vertex as the output. It is the y-intercept value as well, and is the value of k. So, what is the transformation? How did the parent, which is in pencil over here, change to the one in blue? A lot of people will say that the parent is bigger, it's wider, and I'm going to tell you that it's not, and I'll prove it. So we take a look right here. This is an outline. It fits exactly over the parent. Now if I were to slide this transparency up, notice that it is covering the new problem exactly as well. Ladies and gentlemen, these two parabolas are of the same width. It's an optical illusion to say that the parent is bigger than the offspring. We simply see more of the parent graph, and it gives the illusion that it's wider. But again, as you see when I put the overlay here, I'm able to cover the parent with this, and then I'm able to cover the offspring with the same graph. I just happen to see more of the parent than I do of the offspring. So it's very important that you realize that they are not wider. We're going to get to that later, just not right now. Describe the transformation from elementary or middle school. Remember we did translations, reflections, rotations, slides. We did a translation. We slid the original one up 1, 2, 3 units. So we have translation of the parent up 3 units. That's what happened here. Now, the good news about parabolas and domain. All parabolas will have the following domain. Every single one of them, whether they're facing up, smiley face, and later on we're going to have parabolas that open downward. It'll be a frowny face. It'll have a maximum instead of a minimum. But for every single one of our domains, it is forever increasing to the left and the right. So these little arrowheads are continually going out this way. So what we can do is say that it goes on to negative infinity to the left. We can't touch infinity. Domain is x, and then it'll go to positive. For every single one, for every packet we give you, every problem we ask you to do, that can be your domain. Okay? Now the range is different. As we look over here at this blue guy, there's actually a low value or floor or bottom number, or valley number, whatever you want to call it. But this vertex is the lowest that it goes on the y-axis. Well, what is that point? What is that y value? That's a 3, and we go through that point, so we actually touch that 3. So 3 is going to be our lowest value. We touch it, so it's equal to. All of the other y values go up for infinity because they have arrowheads going up. And that's how you do that. Now there is one thing that I want to show you on problem number 2. I want to show you on problem number 2, we actually do have zeros on problem number 2. And I'll show that to you real fast. So when we go to graph this thing, here's our problem. We're going to come over here and change this to -5. And when we graph this, you can see right here, we've got 2 points. We've got this point right here, crossing the x-axis between quadrants 1 and 4. And we've got this point right here, crossing the x-axis between quadrants 2 and 3. So we do have something to put for 0, 1, and 0, 2. It doesn't matter which one you call the left one 1 or the right one 1. It doesn't matter. I just have 2 of them. So I need to identify them. Here's how you do it. It's a calculator keystroke. You ready? We're going to do second and trace. If you notice right here, what are we trying to find? We're trying to find a 0. So there you go. Second trace, we're going to find a 0. Now when you find zeros, you have to do them one at a time. So if I come over here and I want to do this 0, I have to move this cursor to the left of this point. So right now, this cursor is to the right side of this target point. So look at the tip of my pencil and the cursor. the cursor is farther to the right, but the calculator wants it farther to the left. So I'm going to move, using my arrow button, I'm going to move it so that the cursor is to the left of my target point. So is that blinking light farther to the left? Oops. Hit something accidentally. Let me start again. Second trace, do 0. Is that left? Okay. So if it is, just press enter. And then it's going to say, okay, well, what about the right of this target? Okay. So now we're going to move the cursor so that it's clearly to the right. So now, do you agree that this blinking light is to the right of my pencil point? I hope you say yes. So hit enter again. Tell the calculator, no, I don't want to guess. And we have right here, it'll tell you the value that the x-intercept is. So in this particular case, one of my zeros, one of my x-intercepts is going to be a negative 2.24, a couple of decimal places. And there it is. Now, in order to find the other one, I have to do the same keystroke a second time, which is second calc. I'm going to find the 0, but now I'm going to target this one over here. So I'm going to move my cursor, and it wants me to be left of it. So I can leave it right there if I wanted to. It's clearly to the left of that target point. So I'll hit enter. And now I want to move my cursor to the right of this point. So I have to get it to shift sides, and now it's clearly to the right of this point. So I'll hit enter, and I'll hit enter a third time, and it'll tell me where it crosses the x-axis. So my other 0 rounded is going to be 2.240. All the other stuff, filling in the table and the maximum, minimum, vertex, and transformations is going to be the same on all these problems. Hope this helped.